All right, guys, so we've just gotten back from collecting our flights. We've gotten that data passed around, so we are now ready to dive into LP360. So to start off, we're actually going to go through some things we want to get set up before we actually start working. So the first one, we're going to stop off at the license manager to make sure everyone's able to check out their license. And this will be the very first stop. So when you start up LP360, you will see this startup dialog, and we're looking for the license manager down at the bottom. From there, it may not show you having a checked out license at this time. So just to verify that, I'm going to go into my credentials, and I'm actually going to log in to my training organization. So I'm going to use my LP360 portal username and password. Sign in. And when you do that, LP360 will actually pull down the licensing from your portal. Okay, so right now everyone should be in our training account, but for those of you at home, you will see that this is going to be your organization's specific license string that populates here. When I click OK, it will let me know if there's any issues with connecting. In this case, there's not. It's able to successfully pull that down. If you are going out into the field to go collect your data, you may end up wanting to roam your license if you're not going to have internet connection. But do take consideration for the number of days, because once this license is roamed on your computer, it can only be removed either after the number of days has passed or if you manually check it in. So if your computer breaks or if you take a vacation or anything like that, this license will remain on here. Nobody can remove it except for you. So, but since we are in our office with internet connection, I'm not going to roam this one. But I am going to go ahead and check out that drone license. So that's the one we're going to need for today, our drone license. Okay. Once that's successfully checked out, I'm going to close it. You should see that little startup dialog pop up again. But as I mentioned, we're going to go through some of the project settings before we even start importing our cycles. So I'm actually going to click cancel here. I'm going to go up to my project ribbon, and I'm going to look for the settings button. The settings button. Okay. So the very first thing that we want to set up is our default project root folder. So this will be the location that LP360 will automatically pull down for your projects. So for example, I will be doing multiple December trainings. So I actually want a December training folder. So every project I create will go in there. So for example, if you know you have a big project site coming up, you might end up having several LP360 projects in there. You may want to set up a folder for that one specifically. So I will just click my three dots or my ellipse here. And I'm going to go into my training folder. You can see I have one for November and October, but I don't have a December. So I'm going to create one. So December training. So now all the new projects that I create will go to this location. So this just helps for organization and being able to locate your projects later on. On the global tab, because I do recognize that we have people that use other different types of softwares. So you may want to come in here and change the mouse wheel zoom. So you can invert that. So if you're used to using AutoCAD or something of that nature, you can modify that here. The next thing I want you to do is I want you to set up this notification email. I want you to take note that this is not the same email that's listed right here. So this one is actually used when it's sending you notifications and things like that. And if LP360 ever crashes, so it loses connection with the license server, it will use this email to send in that crash report to our developers so that we can figure out what's going on and help you troubleshoot it faster. So I do recommend you go ahead and set up that email. The next one is going to be your working directory. Now this is necessary for multi-cycle processing and for your TrueView 540s and your TrueView Go. So as I mentioned, this does have a specific tool called our sensor processing tool that uses this particular directory. It can be anywhere you like it to be on your machine. So I actually have a working folder that I've created, and I created a temp folder inside of that. It's not a predefined location on your machine. It's wherever you would like it to be. The next thing is going to be our TrueView tab. So this is where that downloadable I mentioned before needs to be. So that's going to be this one right here. This is the POSPAC QC.executable. Now, if you already have this downloaded on your machine and you have not executed it yet, I do want you to go ahead and execute, and it will actually create a folder in the same spot on your machine as it is on my machine. So it stores in the same location. So when I click this ellipse, even if this was entirely blank, it would actually drive me straight to that location. So if you ever need to upgrade to a newer version or something of that nature, I can go to my Applanix folder right here. This is every single version that I've ever installed. Okay, so you'll have all of them here, and all of them will be stored in the same location no matter what machine you're on. So you're just looking for that QC and then the latest number. So for us right now, it's 9.4. Okay. So you do want to just make sure that's open. It will actually automatically find this executable inside this folder. You don't even have to locate it. You just need the folder location, and you can open it up, and you're done with that part.
I don't
Yes.
have anything in the first line there for TrueView settings.
So this one right here is for local processing. So local processing is actually only configured for specific payloads. Those payloads are typically referred to as a classic model and some of our traditional models. So it is not required for all users. So you are informed at the time of purchase if you have a local processor for your particular payload. If they do not tell you that it's local, it's going to be through the cloud, you do not need that second executable. Okay. The next one is the EXP tab. So there's a couple of things I want to talk about here. So first off, if you do have a Agisoft Metashape key, so you are intending on using Agisoft Metashape on your machine through LP360, you do want to do the activation here. Okay, so that is something you would want to go ahead and set up. Not all of our users have it, or if you're processing it through the cloud, you don't necessarily need this key. The last thing I want to talk about is our pyramid settings. Okay, so if you know that your computer only has a limited amount of storage, I do want you to take note of under my LP LAS, mine is set to backup because I don't like it overwriting my files. I like to have the backed up data so that I can always revert back to the original file if I ever need to. If you're worried about using up too much space, you may want to change yours to overwrite. Okay, entirely optional, but those options are available. QVR, so the second option you see down here, is an older pyramiding type. It does not work for all of our tools, so I strongly recommend that you stick with the LP LAS format. Does anyone have any questions on the settings that we just went through? Yes?
Should I also have my machine on backup instead of overwrite?
That is entirely optional. Like I said, I prefer the backup just because you'll always have basically a second copy of your original data. I like to be able to go backwards if anything ever goes wrong, but you are more than welcome to use that overwrite option. I think a lot of our other technicians use overwrite as well. All right, so once all of that's done, I'm just gonna click apply and okay, so I can close this out. And now we're gonna set up our archive because our archive location needs to be predetermined before we can actually use it. So I'm gonna go to my sensor tab. I'm gonna go to my archive manager up here. And when I open this up, you may notice that I already have a lot of locations. So your archive does not have to be a location on your machine. It could be a network location. It could be anywhere that you like it to be. So you can actually see I have a network location for every type of sensor that we have here at GeoCube, but I also have one set up for all the trainings that I've done in the last couple of months. If I ever didn't need one anymore or something like that, so let's say this August training was not of use to me, I can actually click remove and it will be taken from my list. If you ever have an incorrect location set up, so maybe the folder path is incorrect, you may notice there is an edit option. This edit only lets you edit the name. It does not let you edit the location. Okay, so you would need to create an entirely new one, but you can actually see the cycles I had stored from back in October. If I did decide to use the ones from October, I could actually copy those to a new folder if I wanted to. I could move them to a new folder. I could update them if I needed. So if I needed to add ancillary files or anything like that, that is entirely optional when you have this already stored. Now, since we collected new data sets today, we do want to archive those, so we need a location. Yes, did you say so? Oh, I just saw this, so I was like, oh. Okay, all right. All right, so we're gonna click add, and inside of my December folder, so training, December. So I'm putting all my stuff together. I'm actually going to create a new folder in here called Archive. Okay, just like that. I'm going to select that folder, and then I'm going to name it my December training. Okay. Click OK here, and it will add that to the bottom of my list. So I'll scroll all the way down. Here it is. Okay. I do want you to take note of this archive up here. So this is the cloud storage. Even though you see this in the manager, it is not an option to import directly into. This is something that you would want to copy or move cycles from an existing archive into the cloud, because we don't make the assumption that you have internet connection when you are importing to archive your data. So we want to make sure we're safeguarding against that, so we make sure it's a location we can actually access. Okay. So now that we have that location set up, we are ready to import our flights. So I'm going to click close here. I'm now going to go to my cycle import, and I'm going to select import and archive my flights. So like I mentioned before, we are pretending like we are the flight operator out in the field. This is the recommended workflow for this, because we want to review our data, we want to do our QC check, and we want to archive and store a backup of that data so we don't have to worry about anything happening to it. So onto my next page, I'm going to click my folder icon. If you already had archived data, you could use your archive manager. So if that was a processor later on. So that's another reason to have that. All right, so in my training folder, training cycles, I want y'all to find that December folder that I gave you. And you should see the name of both of your cycles. Okay, they're right here. I want you to select both of them. And then click Select Folder to add them to the dialog. When you do this, you may see a pop-up. If you ever see this yellow icon, it is not an error. It is a warning saying, hey, read me. So if I take a look at this, it's telling me that there is a firmware update available for this particular sensor. Again, this does not mean there is an issue. It is letting you know there is an update available for your payload. So I'm going to click OK here. It will pop up for both of those cycles since I did have two from the same payload, and that's perfectly fine. Now, for example, if I wanted to add in my base stations and my checkpoints that I collected out in the field into my archive. So let's say I was setting this up to a network. I wanted to make sure that my processor had those files later on. I can go right here into my ancillary folders. So I'm going to double click that. In that same cycle same training folder, so December training, the one I gave you, you'll see there's a control folder. Inside of that, you'll notice there's several different files. If I select all of these files, so I'm selecting all of them, clicking open, these will actually be stored alongside my cycle. Now, ancillary files do not impact your data in any way, shape, or form. They are extra files that you want to have access to in the archive. So if 3 months down the line, if I wanted to download these archives and use them later on, I would have this additional data with them versus having to go find it later. I'm going to click OK, and you'll see it populates right there. You could also add a description if you wanted to. So this is just something that'll be stored alongside these. So I'll just say this is the day 1 training. So then I know we created it today. So I'll click on the second one. I'll do the same thing. Day 1 training. Just like that. Okay. The area would be if maybe you have your project segmented into quarters or something like that. You had some kind of indicator of what section it was. You could always come in here and enter that in as area, but that is entirely optional. You do not have to do that. On the next page is where you can add in your base station observations. We are not using those today, but I do want them stored with my archive. Okay. So I am going to go ahead and add them in just so it's stored alongside that data for later usage. So not the December training cycles, December training, base. So you'll see a base folder. That will have our base observations in there. So that way, once again, this will be stored with that archive. I don't have to worry about going to track these down later. But if you're out in the field and you don't have your base station observations, you can completely omit this step because again, we are not using those today. All right. Finally, we're going to set up our project name. You can actually see right here where it's pulling down that project root folder that I specified earlier. So I don't have to specify a location. I just have to specify the name. So I'm just going to call this one day one in person. So I know exactly when I created this because we do host these trainings every single month. So I do try to keep them in a similar fashion. Now, if you guys just want to pause for a moment, I'm actually going to talk about my coordinate systems, and I am going to review these tomorrow as well. But I'm going to teach you how to utilize this drop-down and utilize the coordinate system dialog. So let's say, for example, I have a coordinate system in here that I don't like. Maybe I accidentally selected it. Maybe I never need to use it again. If you would like to remove it from your drop-down, because as you can see, it gets pretty long, click this X button and it will remove that from your coordinate system list. Now, when it's blank like this, of course you need some coordinates before you can import. So we're going to go into the dialog to select it, and there's a couple different methods to do that. So again, if you just want to watch for this part, or if you just want to enter in the coordinate system, I give you this time, you can click OK and then just watch for a moment because I'm going to go through all the different options here. So the first one is you can either browse by going through your folders by clicking these little plus buttons to go find your coordinate system, or you can actually enter in what's called an authority code. That is a unique code associated with the horizontal coordinate system. Now for the one we're using today, that's going to be 6355. Okay, 6355. When I enter that in, you'll see it takes me directly to my coordinate system. If you would like to find this code for your own coordinate system, go into the description, scroll to the bottom, and it will be the last authority code listed for the horizontal. This is not going to be for the vertical, only the horizontal coordinate system. Okay. For the vertical, we're going to be using the ellipsoidal meters. So from here, you guys can just go ahead and click OK. This will be the one we're using. But I'm actually going to click the Save PRJ. So I'm actually going to save this. I could actually include this as an ancillary file if I wanted to. But under my training folder, I'm just going to put it in the archive itself. Call this Alabama meters. Okay. So I'm actually going to cancel this out so you can see that it's completely blank. Now remember, I saved that PRJ file, and you could store it later on. You could give it to maybe a colleague, to a client, someone you want to make sure has the same coordinate system as you. They can just come back in here, click Select from File, click this little ellipse or the three dots, and go find that PRJ that you saved. Okay. You can then click Open. It will populate with the entire coordinate system. You can then click OK, and it will populate your dialog. So those are the options for getting your coordinate system in there. Okay. On to our next and final page. We're actually going to choose what archive we want our data to go into. So remember, I created that one for December, so it's down here at the bottom of my list. It is going to have one final page for us to confirm all the details, so you can actually see my base station observations. One of them says multiple files, and one of them only says one. That is because it is able to parse the start and end times for these particular files and identify what base station is associated with what cycle. So it's going to handle all that for us. You can also come in here and enter in your reference mark. Again, we're not using that today. We're going to enter it in tomorrow. You can check out the other details about your cycle, so its path, things like that. And once you've confirmed this looks the way you want it, click Finish, and you will begin the import and archive process. Now this can take a little bit of time, so we are going to sit in silence while we do this. Yes, very fun, I know.
When you put in your reference system, did you put anything in for vertical?
The vertical was ellipsoidal meters. Mm-hmm. You do want to make sure that the coordinate system that you're selecting, that frame, so the NAD 83 2011, that's the one we chose, is the one that your base station was collected in. So that's where you want to make sure that frame is matching. Mm-hmm. So that would be whatever you collected your base station in. So your surveyor would know what that's done, or your field operator. Mm-hmm. All right, so it looks like our flights are now imported. So whenever you have a freshly imported cycle, they will come with 4 different feature layers. So that's going to be your photos, your trajectory points, your log points, and your trajectory line. Now the only one you're going to really be working with is the trajectory points, because we're going to use that to create our flight lines. So that's going to be our very first step, is to create those flight lines. So I want you to find the Auto Create Flight Lines tool. We're actually going to be moving from left to right on this ribbon. And this tool actually allows you to create flight lines for multiple cycles at the same time. So if you have multiple in your project, you can actually edit and create those all at once. Now, we do have 3 different parameters for this. So the first one is going to be your minimum length. This is going to be the shortest desired length of your shortest flight line. You have your turn radius, which will actually trim your flight lines away from the detected turns. And then you have your maximum deviation. So that means if your flight line deviates up, down, left, or right by, in this case, 10 meters, it will break it into 2 lines. So if you are following terrain, you do need to increase this value to make sure it doesn't snap your flight line into a bunch of smaller ones. Okay. If you wanted to estimate your minimum length, you can actually use the measure tool right here. So a helpful little thing I like to do is I actually will pause this functionality during measure. So I will left click once, find the bottom of my line, and then I actually right click to pause the functionality, because otherwise it will continue to track my movements around. You can then look down here at the bottom, and this will be that estimated measurement. So in this case, it's roughly 100 meters. So since it is going to be trimming away from our turns, we do want to round down a little bit. So maybe I want to use like 90 or something like that. So I'm just going to change back over to my pan, because I don't want that measure tool tracking me all over the place. And I'm going to type in 90 here, and I'm going to leave these other 2 as 3 and 10. I'm then going to click the Compute Flight Lines button, and it will actually create the flight lines using those parameters. Now, using this tool, you can actually run it as many times as you like. So if you were, for happenstance, dissatisfied with maybe your turn radius, or maybe the max deviation caused it to break your lines up into pieces, you can modify these settings and run this tool as many times as you like. Now, there is a way to manually edit and create flight lines. We're just going to hang up on him real quick. Sorry, Thadia. But I'll be doing that on the next one. Even though maybe we don't need to do it in this instance, we are going to get some practice in for creating those. So on to the next page, it will enable what's called edit mode. Edit mode allows you to automatically, enable your select tool. Mine is set to the polygon, but if you would like to change the type of select tool you have, you can do that here. So it's the lasso that I have. And it will also swap to 1 cycle at a time. So you can actually edit those as expected. The last functionality, and why you would want to edit your files while this is open, is it will automatically save all of your edits. If you close this dialog and edit them, you will have to go in and manually save them, or you may risk losing some of your progress. So do keep that in mind. All right, so I'm going to turn off my Google Hybrid so you can see these a little better, and I want you to take note of this curve. Now, realistically, a curve this small is probably not going to impact your data. But if you had something a little more steep, you would definitely not want it included, because if it changes the orientation of your photos, it can cause a domino effect later on. So that's something we'll dive into a little bit more tomorrow. But for this exercise, I am going to delete this flight line and create a brand new one. So I will actually select this line, click the delete key on my keyboard. It will ask if I want to confirm that, and I can click enter to remove that one altogether. Now, to create a new one, I'm actually going to come into my table of contents, find the flight line layer that's turned on, and look just beneath it. You'll see trajectory points. We're going to turn that on. I'm going to select a point at the start of my flight line, hold the control key, select one at the end of my lines, and then I'm going to click manual flight line. So that button right up here. That will actually digitize this new line. Okay, so I'm just going to check my other 2. So let's say for this example, I don't like this one. I will select the flight line, delete, and enter. select the first trajectory point, hold the control key, select the second, manual flight line. Okay. And like I said, this will automatically save all of my edits. You will also see the status has changed to edited, so I know which one I've worked on and which one I haven't. So if you have even 10 flight line layers, you can still figure out those without having to guess. All right, so I'm now gonna go to my second one. Now this one actually has a transect line right here. You never wanna include these. So typically these are gonna be flown at a different speed. You're gonna have a lot more dynamic movement. So there's probably not good trajectory or good points in that particular flight line. So we wanna get that out of here. Okay, so delete and enter. Now again, for the example's sake, I am gonna create a new one up here. So I'm gonna select and delete this flight line. Move this out of the way, go find the trajectory or the flight line layer that's turned on and turn on the trajectory points right below it. Select a point at the beginning, hold control, select a point at the end, and manual flight line. Does anyone have any questions on our flight line creation? If I have no questions, we will close it.
I have a question.
Yes.
The unique flight line, could you create one transverse to your actual flight path?
No, this has to be wherever you actually flew. So it would have to follow your physical path. Yeah. Yeah, because this contains data about your trajectory. So that's why it's able to create that information. The flight line layer itself is actually used to trim the LAS data so that you're only keeping those nice straight flight lines. So you're far more likely to have like a consistent movement. So your LAS layer will actually look more consistent versus, you know, if you're slowing down, if you're speeding up, if you're turning, that can change your point density and impact those areas. We typically don't want that information included. All right, the next thing we're gonna do is we're gonna click the sensor processing button. If you were not interested in geocoding while you were out in the field, you could also just do trajectory. Because today we're gonna do the entire check, so we're gonna look at our trajectory report, and we're gonna make sure that our LAS is covering our area of interest. So we're making sure there's no gaps or anything like that. So sensor processing allows you to do that multi-cycle processing that I mentioned earlier. And it looks like I made it crash. So as I mentioned earlier, it's actually reading that email I put into my settings. So this is actually very important. So I would be able to tell the developers what I was doing. So I'll say opening sensor processing, and it crashed. It doesn't have to be really long, but putting in some kind of description lets us know what you were doing and allows our developers to actually fix that in LP360 if there was something going on. So maybe it was storing too much memory that caused it to crash out. Maybe there was a misoperation in the code, something like that. But I can very easily reopen my project. So there's my day one in person. And let's give that a go again. All right, so this time it did not crash. So as you can see here, sometimes it can just be a unique set of circumstances, a unique set of steps that can cause LP360 to basically get ahead of itself. And having that setting in place where you have that email allows you to still communicate with us about what's going on without you having to do anything. Okay. So as I mentioned, we're gonna do that QC trajectory processing and we're gonna geocode because we wanna see where our LAS actually exists. So on to my next page, I'm actually gonna configure my settings for trajectory. So to do that, I'm gonna click the little gear icon here. It's gonna open up and it's gonna default to single base. But remember, today we're functioning like we are the pilot out in the field. We wanna switch over to the QC only process. And you'll notice the other settings kind of go off. That's because it is going to generate a report for the entire extent of our flight line, or our flight. And that's what we want it to do. So on to the next page, it's just gonna ask us to confirm these details. You'll see right here, it says QC only as the processing mode, and it's gonna run it locally on your machine. That's what we wanted to do. So I'm gonna click OK here, and you'll notice the status changes to edited, and it's no longer red. So that it's not asking us for any additional information. Now, since I'm going to be using the exact same settings for my second cycle, I'm actually going to click the copy tool here. I can select that second one, and I can actually paste those exact same settings. So it is going to ask for confirmation here. It's asking me if I really do want to do that. The answer is yes. And that way I don't have to open that dialog again. I don't have to mess with it. Okay. If you notice that this dialog did not open for you, or if it's only reading a single cycle, that is because you don't have an unlimited license. So the unlimited license enables the functionality for multi-cycle processing. Okay. Okay. You should be in our training account in the top right-hand corner. What organization does it say for you? It says yours? Okay. You can still follow along with us. It'll still be all the same settings. If you want to, for tomorrow at least, we can get you into the training account, and that way you can test out the unlimited, because you will have access to our licensing. I'm not sure why you don't have it now, because you should have been moved over. But
I was supposed to get another email. I never got one.
For a second email for
Get into the training account or something.
okay. Can you tell me your email real quick, and I can get someone to fix that at our lunch?
Tony.Sheffield@Boulder.
You said Sheffield? Okay. Yeah. That won't take long. I just got to go get with someone that has the admin privileges to move you over. But either way, you can do the same steps, but you can just do it for one cycle if you want. Tomorrow's when we're really going to dive into everything. So either way, you'll still be able to keep up with us today. All right. So those settings are done. We're now going to look at our geocoding settings. I'm not actually going to change any of these, so you're more than welcome to just sit back. I'm just going to talk us through them, and I will review these again tomorrow as well. So, all right, so I'm going to open these up. You'll see here, this is where our clip angle is actually entered in. So for most TrueView units, that's going to be 40 degrees. But for example, if you're using, that 540 or anything like that, you may need to decrease this a little bit just to make sure you're getting only those colorized points. You're not getting those outer points outside the field of view. If you wanted this to run a little faster and you were not interested in the colorization, you could disable this if that was of interest to you. For today's exercise, we're actually going to leave both of these turned on because we are checking both the colorization and the coverage of our point cloud. But like I said, it is optional, and you can always colorize outside of this as well. All right. Now you're going to see another pop-up. So this is a different icon, the little blue one. That one is asking for your confirmation before it continues on with this step. Now, what it's asking me is it's saying there is a newer calibration file associated with this cycle. Do I want to use that? The answer is always yes. I still recommend you stop and read these just to make sure you understand what you're clicking yes to, but that's all it's asking. So you will see this one says edited, and this one still says default. So once I click submit, and it begins sending those off to the job manager, it will ask me about that second cycle because I did not confirm already. That's what I wanted to do. So PPT, or post-processing trajectory, that's going to be our trajectory jobs. Just going to click OK here. And now it's doing that geocoding. So here's that second job. It's asking me the same thing. Do I want to use the latest calibration file? The answer is yes. I can then open up my job manager, and I should see those jobs appear. Now, right now, I have all of my jobs that I've ever run open in LP360. If I would like to only show the ones that are actively in progress, I can come up here to where it says state. I can actually turn off all my completed and failed jobs, so it'll only show the ones that are in progress and the ones that are queued, that are ready. So basically the ones that need my attention. Click OK. And that way you don't have to look at all those other jobs if you don't need them. Okay. So we will see one of our PP jobs is already done. So that's our post-process trajectory. So I'm going to select that and click complete job. And then it's going to ask me if I want to view this report. The answer is always yes. Look at these reports. It's very important you verify your trajectory. So I'm going to click yes here, and it's going to open it up. Okay. Now this is going to look different than our report that we'll be viewing tomorrow. but I'm still going to go through this information the same way I would do if this was my actual data that I had just collected. So I'm going to zoom in a little bit here so you can see a little bit better, but I want you to take note of the project name. That's actually the name of your cycle. Okay. If you look down to processing mode, you'll see where this lists unprocessed. So that's how we know this is our QC only. Okay. The next stop I'm going to do is go to the rover data QC. Okay. Rover data QC. You will notice I view by my outline versus scrolling through the pages. So that way I stop at very specific headings along the way. Now what we're looking at here is actually this first graph. All right. So this is actually showing us our satellite lock during flight. Now what we're looking for is we're trying to make sure at any one time we have at least 3 solid green lines. So that means we have at least 3 satellites at 30 degrees above the horizon for that satellite lock. Now all these little red dashes you see at the beginning, that's actually when we're powering on the sensor, and that is what we call a cycle slip. A cycle slip is when you lose connection with the satellites. You can actually see a few throughout our flight. As long as this pattern that you see here is not seen in the middle of your flight, you're okay. However, if I saw a straight line of dashes like this in the middle of my flight, I would want to go ahead and refly, because that means you lost connection with those satellites at that time. Even though you might be able to bypass that, you might still have accurate data, you're still taking a risk with your trajectory having some kind of degraded solution. Okay. In this case, we don't have any of those cycle slips that go all the way down anywhere in our flight, so that's good. The next thing that I'm going to stop at is my real-time trajectory information. Now what I'm checking here is I want to make sure that this appears like my flight path. Okay. This needs to look like my flight. If it looks like it flies off into oblivion, something went wrong. I need to refly. Okay. We're going to do the same thing with our altitude. We want to make sure that along this axis here, this does appear like our planned mission altitude. In this case, this is 70 meters. That's what we planned for, and that's what we expect to see. So this is good. The last thing that I really like to check that I think is incredibly important to verify is I'm going to scroll down to my total speed, and I'm going to tell you what I'm looking for here. Now this first little bit here is actually where we are flying up to altitude, because this first part is actually trimmed off when you do single base later on. It's only seen in this QC. So that's why I want you to check it. I want you to notice these 2 spikes here that come at roughly 10 meters per second. Those are your heading alignment maneuvers. You need to see these 2 lines at the beginning and end of your flight. Okay. The one that follows it, so this little shorter spike here, that's actually where we are flying out to the start of our mission. And then when it kind of levels out a little bit here, that's where we're actually performing our mission flight. Where you see the speed drop a little bit, that's actually where it's slowing down to do those turns. Okay. Once again, we see those heading alignment maneuvers at the end of our flight. We then see the speed spike up as we are returning to our home point, and then when we are landing our drone. Does that make sense for everything I just talked about? Okay. So I'm going to do the exact same thing, but for the next one, so we can review all that same information, but I'm going to go a little faster. All right, so we can see our next PPT job is complete. I'm going to click complete job, yes, and again, yes, review that report. All right, here's my cycle name. I'm going to review that outline, rover data QC. I don't see any cycle slips going all the way down. That's good. Real-time QC. This does appear to follow my flight path. The altitude is at 70 meters, which is what I want to see. Down to my total speed. All right, here's my 2 heading alignment maneuvers. Flying out to the start of my mission. Flying the mission with my 2 little turns in here. Heading alignment at the end. Returning home. Okay. See how quick that was? Saves you so much time and so much trouble taking those few seconds to review this report and make sure you have a solid connection. All right. Now, the next thing we're going to do is we're going to actually inspect the point cloud, see what it looks like, see if it covers the area we expect it to. So I'm going to complete this job here, and it will actually begin geocoding. All right. And it looks like my other one's done, so I'm going to go ahead and complete that one as well. All right. Looks like they're both done here. So now we actually get to take a look at their coverage. So I actually have my single LAS mode enabled. That means it's only going to display a single LAS file at a time, which is what I prefer. So I can actually see all the coverage that I get. It does go quite farther out than our flight lights themselves, because you are going to have that outer spray. But as you can see here, how the pattern starts to get a little distorted. That's where you could start to see some of those end of scan lines or bad incident angles, things like that, which is why you want to make sure that your targets and your objects of interest, so the things that are important to you, are on the inside of your flight lines. Even though you can get this coverage on the outside, you cannot guarantee the accuracy out on these outer edges. Okay. I'm also looking at some of my targets. So if I zoom in here, we can see all these cars, and maybe I want to make sure that my colorization is actually coloring the car itself. So I can actually change my display to elevation, and I'm going to change this to a 10. 10 actually allows you to see the surface. Now remember, this is our unprocessed data, so it's going to look a little fuzzy. But I can see this is a distinct shape of the car. Change back to my RGB, and it is actually overlaying that shape as I expected. Same with the edge of my roof. I am seeing those colors sticking to the roof and not going over onto the sidewalk or anything like that. Now these extra little points out here that you may see where it looks a little discolored, that's okay. That's one of those bad incident angles. They can happen at the very edge of your scan line. That's okay. Okay. So in this case, the cycle ending in 4-9 looks good. I'm okay with this so far. I'm going to switch over to the other one. So it's a cycle that ends in 38. I'm going to do that same general check. Look out here. Does everything look and cover the area I expect it to? In this case, the answer is yes. It looks good. Now I'm going to zoom in on a different area. Let's say we want to look at these little guys back here. We've got some little things. Now again, this is going to look fuzzy because it is unprocessed. Tomorrow when we use our base stations, you'll notice this looks a lot cleaner, a lot more precise. All right, so I'm going to do the same thing, my 10 surface, and do my elevation. And that looks really rough. That's really hard to see. But a way you could visualize single objects is you can actually use a 3D viewer. And so I'm actually going to just draw it right around this one little thing here. So we can notice, you know, it does look like there's some separation. There's going to be some poor trajectory in there, but we can still kind of see our objects. To make it a little more defined, I could try this. I can actually see where they stand up now. Find my RGB and just make sure that red color is actually sticking to the stuff that's on top of the concrete. And in this case, it is. So based on everything I'm seeing on this unprocessed, unrefined data, this was a good collection. I'm then good to move on to my next mission or what have you. Now for today, we are going to do some additional assessments, even though, again, this is not intended for deliverables or anything like that. We are going to go through a few extra steps to prepare us for tomorrow. That way we just get additional coverage on some of these topics, including strip alignment and our accuracy estimation. All right, so the first thing I mentioned is strip align. So remember, I said we're moving from left to right. Now this post-processing dialog, this is typically intended for other sensor types, such as our DJI, our Wingtra, maybe our 540, things like that. And it allows you to do all the same geocoding steps, but you could do it on any data set that you have in here. So it's not unique to the TrueView sensors, whereas geocoding, it's going to be TrueView specific. Our strip align, however, is intended for all sensors as well, but this is the one where it helps to refine that point cloud, really help to clean it up. So for example, I want to check how my point cloud aligned. Now keep in mind, This is unrefined. It's not going to look good, so we're definitely going to see some fuzziness, okay? I'm going to draw a profile across my roof. Now, you may have noticed I didn't start to drag to specify that. I left click on both sides that I want, and then I right click so I can enter in a depth. When you are looking at the definition of your point cloud, you want it to be very narrow to ensure you're actually able to see the definition and not see all of those objects smushed together. So I'm going to do 0.3 as my depth, 0.3. Now, while I'm looking at this, as I mentioned before, there is going to be fuzziness. This is not going to look good, but that's okay. Tomorrow, we'll really dive into those nitty-gritty details. But for now, I'm going to stick with this, and I'm actually going to change this display to point source ID. Point source ID is the value associated with each individual flight line. So when I'm looking down here, let me increase this size a little bit of these points so it's a little easier to see. There. Now I want you to take note of how those colors are very distinct and separate from each other. You're not seeing all that mixing. This means there is separation in the trajectory that would need to be corrected. So in this case, we would absolutely want to run strip a line. Absolutely. Now I can actually check my other point cloud without moving anything. So I'm actually going to come right here to my active LAS layer, because remember I have my single LAS mode turned on. And I'm just going to switch over to that other one. It'll actually show me that point cloud in the exact same location with the exact same display. Okay. So again, we're seeing those distinct colors kind of stacked on top of each other. This is another example of when you would want to run strip align. Now, I am going to go ahead and execute this. It will improve it to a certain extent. But again, since it is unrefined, we're still probably going to see some fuzziness. It's probably still going to look like a really thick point cloud. But tomorrow, you'll see when it gets really thin and much more precise. So in my misalignment, I'm going to click Use. And because I have such a large separation here, so this is large meaning over 10 centimeters, I'm going to choose the large misalignment option. If this was under or at 10 centimeters, I would want to use the small misalignment, but we have a lot more stuff going on here. Now, you may notice it also is going to default to the same type of naming scheme. I do think it gets a little long when it's adding all this stuff, including the date and time. So I normally end up shortening this to something. So I'm just going to say strip align QC. Okay. So just something short and sweet. I'll click submit and it'll actually send it off to the job manager after I confirm those details, so you can actually see where it says use and 0 fixed. Fixed means that will not be included in the output. It is used as reference. So I want both of them included. I don't have a corrected reference LAS layer at this time. So I'm going to click yes. And in that job manager, I will see it executing. So for this job type, it is referred to as an SADJ. I don't think I mentioned before for geocoding, that is going to be the TVSP. Those are the types of jobs that you'll see there. You can also see the identifier, the project name, a processing message. If you slide over, you'll also see a lot of additional details about it. Now we let this run. Sometimes it can run longer than on different projects, depending on the level of corrections and the amount of data that has been input. So if I have 10 cycles, it will take a lot more time than if I have, say, 3. Okay. Same can go with if I have a 30-minute flight versus a 10-minute flight with the same scanner. 10 minutes will take a lot less time to correct than the 30-minute flight because it's a lot more data. If you wanted to monitor the status a little bit more, so you can see there's a little plus button. If that ever appears, it means it does have subfolders in there, and it has multiple things that it's going to run to execute this entire task. So it just performed the corrections and re-geocoded these with those corrections in mind, and then it does what's called a RPJ or reprojection, just merging all of those together and making sure it's in the correct coordinate system before it completes that job. So now that it's ready, I'm going to click complete. Yes, and it will actually add it to my map layer. All right, now take a look at this. This is our strip aligned layer after we performed it with both of those unprocessed point clouds in there. Now, just to really highlight the difference here, I'm actually going to change my graticules. So that's what this little icon turns on, this little grid. I'm going to hold the control key and click this button. And I'm actually going to change this to 0.1 meter. All right, so that way you can really see the measurements we're looking at here. Okay, so that's going to be 10 centimeters, something like that. All right, so now I'm going to toggle between all of them so you can see the separation that this helped to address. So here's our first one. Terrible. This is really off. This is like at least a meter, maybe 1.5 meters. Here's your second one. Again, that's about 1 meter of separation there. And with those corrections from the strip align tool, not only did it bring all of those flight lines together, it helped to refine that trajectory significantly to give us a much more precise point cloud. Now, strip align is an entirely optional process. So if, for example, so if I zoom in here, I want you to notice how all these colors are mixing together. We don't see a distinct color stacked on top of another one. If your point cloud looked like this after geocoding, you do not have to run strip align because your point cloud is already aligned and accurate. Okay, this is intended when you see those distinct colors stacking on top of one another. Now, this is a very extreme example. When we do this tomorrow, we'll still see the same separation, but you'll see it's a lot smaller because it does have those corrections from our base station during the trajectory process. Does anyone have any questions on strip align? Yes, no, maybe so? Absolutely not? All right. All right, so it is 11 o'clock, so we'll likely end up covering all of our material before lunch gets here. So then after lunch, if you guys would like to stick around, ask some questions or anything like that on the hardware side of things, we can cover that. And then tomorrow, we're basically gonna do all the same steps again, but we're gonna go a lot more in depth. We're gonna have a lot more information in our trajectory report to review, so we will go through that as well. And then we're going to get into the strip align of that refined point cloud, smoothing, and a lot of classification and deliverables tomorrow. So tomorrow will be a much longer day. So be prepared to be here until 2 or 3, learning things. Okay. So now that we have our strip align point cloud, we can do our control assessment. Earlier, I gave you a set of files. So one of them is a shape file. If you already have a shape file for your control points, you can go to the project ribbon and click Add Files under Feature, and you can add it directly this way. For this exercise, though, we are actually going to use the CSV file or the ASCII file to create a new shapefile. So to do that, I'm going to go to my control points ribbon. And I'm going to click Import. Import. So this can read CSVs, this can read text files, and other related things. Okay. So I'm going to click Add here. Go into that folder I gave you. So that's going to be our December training, and then into the control folder. You should see a text file down there at the bottom. Okay, that'll be the one we're looking for. When I open that up, you will see information populate down here at the bottom, but you'll notice the next button is still grayed out. That is because it is waiting for me to specify an output location for this new shapefile. So I'm going to click that little ellipse or the 3 dots, and I'm actually going to go into my project folder. So here's my project, and I'm going to create a folder called Control. And I do this for every single one of my projects, so it doesn't matter if I'm looking at a project I created yesterday or I'm looking at a project I created 7 months ago. They will all be in the same format so that I can always find them. So I do recommend you try and find a data structure that works best for you. That way you always know what you're looking for no matter when your project was created. So I'm going to click Select here, and you'll now see that next button is available, so we can move on to the next step. So the next step, you're actually telling LP360 how your data is segmented out. So in this case, if I look down here, I can actually see there's a bunch of commas here. So this is going to be a delineated data set. Now, in this case, we do not have a header record in our data set, but if you at home have a header specifying what these are, you're going to want to increase this to line 2 so that the header is not included as a record. Okay. Since ours does not have one, we can start at line 1 so we can import all of our data in. So that's something important to keep in mind. On the next page is we tell it what symbol is used to delineate our data. As I mentioned before, it is a comma in this case. If you have a special character that is not listed here, you can click Other and actually type in that special character, and it will segment those out into these nice, neat columns that you see below. Okay. Now onto our fourth and final page, we actually tell LP360 what these columns represent. If any columns are left as unknown, they will not import. Okay. So this first column, I want you to notice it is a bunch of numbers, but if I scroll to the bottom, there are some letters involved. If there are letters, this cannot be an ID field. This has to be a name field. Okay. Letters cannot be used as an ID. Okay. For our column number 2, 3, and 4, we would assume that you know what your coordinates are. So those may be unique for your specific instance. For us, column number 2 is going to be y/northing. Column number 3 is x/easting. Column number 4 is z/elevation. Now I am going to repeat those just so that everyone is able to get those. So column number 2 is y. Column number 3 is x. And column number 4 is z. Okay. Now if I scroll over here again, I want you to notice all these abbreviations here. These are the different types of targets. Now, LP360 recognizes these specific abbreviations as specific target types. Now, the reason this is important is LP360 treats each type of target differently. So there is a specific code implemented in the algorithm associated with a checkerboard versus a concentric circle versus an accuracy star, and the FK, that one's known as a full check, that's going to be a painted target. Okay, so that's going to be like if you painted an X on the ground. Okay, it'll treat all of these differently. So column number 5 is type. If we do not specify that, LP360 will treat all of these like a painted target and will only measure the Z. It will not auto-detect the X and Y. Okay. Now finally, column number 6, if I scroll over, it's a whole bunch of zeros and then these tiny little offsets. Now, I want you to see where this type is SA. That is our accuracy star. Now, typically, out in the field, you would have unique values for all of these. Our accuracy stars are set up on permanent poles, so they do have a specific height. They just need a small offset for where the antenna was resting on this accuracy star. So our values are just going to be very tiny, but yours would be unique to your instance. Okay, so column number 6 would be H offset because it's still going to expect that. Once I have all of these specified, I can then click Finish, and it will begin the import and creation process of this feature layer. All right. You can see that does go very quickly, and it will add to the top of our list. If, for example, you wanted to modify the name in your project, so it will not affect the name of the file, I could actually select this layer, click it again, and I could actually change the name if I wanted to, so I could just call it control points. So I could modify that however I like. And I can also change the symbol by double-clicking on the symbol itself. All right, so I could change what it is. So let's say a crosshair. I can make it bigger. I can make it thicker so it's easier to see. And then I could also change the color to whatever I like. Okay. In this case, I'm going to leave it on the pink because it should pop out against that green really easily. Click OK, and you can start to see all those little pink ones appear. Okay. Once that's done, you should also see LP360 will automatically detect that here. And there is our active LAS layer. We want to make sure we are using our strip aligned layer for this process. Okay, so select strip align. It'll update here. Fantastic. And I can now click the accuracy estimation. Okay, so this will actually open the dialog for us to begin the measurement. Now again, if you see this yellow icon, it is not an error message. It is a warning saying, hey, please read me. Now in this case, it is letting us know that LP360 has a set of requirements. It requires a type field, an H offset field, a accuracy X, Y, and Z. So that's 5 fields. We gave it the type and the H offset, but every single time it's going to need to create those other 3 to store the measurements. Okay, so I'm going to click continue to allow it to create that. Now this first dialog here is just to specify the survey method. This does not impact your assessment in any way, shape, or form. This is only giving you an expected level of accuracy for your particular method. So in this case, if I selected, let's say, Basin Rover, this is the level of accuracy I can expect to see. If I used, let's say, the closed loop one here, this is the level of accuracy I can expect to see. That is all that this is here for. If you did not want to specify this, or if you already knew about your particular method, you could just leave this as none and click OK. Okay. Now the next thing we're going to talk about really quick, I'm actually going to just zoom into one of my targets. And I'm actually going to change my display to try and help myself see these a little better. But again, it is still going to be fuzzy, so it's going to be hard to see anything. So I'm going to change this to a 10. And since I have black and white targets, I could actually change this to intensity because that is recorded by the scanner. And I could click on my checkerboard here, and I can actually see that right here. Now again, this is our unrefined point cloud. It's not going to look great, but we can still visualize that black and white colorization. I can change back to my RGB, and you can see it's a little more difficult to see because that kind of blends in with the surrounding asphalt, right? So there are 2 different ways to be able to visualize your targets in front of you. The next thing is we're going to dive into our settings. So if, for example, you had a lot of tall grass, maybe you needed to do ground classification before you got to this process, and you want to make sure you're only using your ground. You could go into your input points filter, and you could actually specify that. To turn off all of these other fields without having to manually go through and check them, you can actually use the toggle all off option here on the right hand side, and then specify your ground. In this case, we have not performed any classification, so I do want to use all of my points. So I can just do this right here, and it will fill those in. The next thing is going to be our method. So sometimes this will default to the 10. You'll notice it actually removes this setting for me, but I want to use the IDW. This gives me more control over my interpolation method. So I can actually specify my fixed radius. The fixed radius is going to be roughly the size of your target. So our targets here are, I want to say, about 1.5 feet across. So that's going to be 0.5 meters. Okay, so that's what we have it entered in here. You could also choose the minimum number of neighbors used in that interpolation method. But typically you're going to want to stick to that fixed radius. Okay. You can also modify your tripod height and intensity coefficient for your accuracy star. I do recommend leaving these as the default. And you can also actually specify the target size for your checkerboard and concentric circles. By default, this does 0.55. Okay, but you can specify that in there. So this fixed radius will be used for all targets, whereas this one is only used for checkerboard and concentric circle. Because remember, LP does treat all of our targets differently. Okay. So I'm just going to click OK here. If I was only interested in the Z measurements, I was not interested in anything else, I can actually enable this delta Z only option and click auto find. You will see this disclaimer every single time you click that button. What this is telling you, and I do recommend you stop and read it, is saying this report does not guarantee accuracy. It is a statistical representation of the accuracy based on the ASPRS standards. Okay, so I'm going to click OK here. It will begin executing. And we will see, if I scroll over, these are our delta Z values. So this is what is the level of accuracy we're seeing. Now, we do have several statistics here. So the RMSE is actually your measure of accuracy itself. The SDOM, that is your standard deviation of the mean. That is going to be your level of precision. So we can actually see this point cloud is very precise, but it is not very accurate. So that means it's probably, you know, up or down from where we need it to be. And that's probably because it's the unprocessed trajectory. That's okay. We could click solve, and we could actually debias by only our Z values. Or since we do have checkerboard, concentric circle, and accuracy stars, we maybe want to get our X and Y measurements in there too. So I'm going to turn off my delta Z. I'm going to click auto find again. Okay. But you'll notice this next thing popped up. That is because to perform the X and Y alongside your Z, you need the 3D accuracy license. If that is available, it will check it out for you automatically. So I'm going to click yes here. It will check it out. It will inform me that that has been done. Click OK, and it will begin that estimation. You'll see it does take a little bit longer to run, but that's okay. That is expected. And you'll now see that our X and Y has been populated as well. Okay. Now we are going to give it a quick review of these different targets. So I want you to notice how several of them have been turned off. That is based on what you're seeing right here, this little message. If targets are colorized, or in this case, the records are colorized in pink, it means they fall on the outer 10% of the confidence interval. If they are colorized in red, they fall on the outer 5%. That does not necessarily mean that these points are bad. It means they are statistically different than all your other targets. So if you wanted to go in and manually inspect these, which I strongly recommend you do, I would go find, you know, one of these targets. So I'd say my checkerboard. You can see it's measuring way down here. It's not measuring correctly. So I could actually turn this one on. I can click measure mode. Normally you would want to do this with an orthomosaic, but for today, this is just for demonstration purposes. So I can actually come over here and click the center of my target or the best representation of it. You'll see that little green mark moved, and all of our values will update in real time for our delta measurements. Now our delta is the error that was detected for that. Okay, so delta X, delta Y, delta Z. Okay. Now I could go through all of these meticulously and fix those, but remember, we are using our QC only data. It's not going to be very accurate in the first place, so I'm not going to really spend all that time doing it. But again, for example purposes, you could click solve and you could actually debias X, Y, and Z based on those corrections. So you'd basically be moving your point cloud to that location. But something about LP360 is it does not actually edit your data directly. It makes a copy of that data and edits the copy. All right. So for example's sake, I am going to let this do it just so you can see what that looks like. Again, we will be covering this more in depth tomorrow. But while it's running, it's performing that debias, so it's shifting everything to our control points to try and make that more accurate. Okay. Once it's done, I can click OK here, close it out, or I could export a report, which is what I'll actually do. So I do export report. You can see my December training, day 1 control folder. And I'm going to call this my control, oops, yeah, that's right, control report _ OG. It's my original file that I created. Click OK. OK, one more time. It is going to ask to save the values that it made or the changes it made to your feature layer. That's OK. Remember, this icon means README. So I do want it to save those changes. I can then switch over to that new layer, which is that last layer 1. Do the same thing. And we should see the values change. Just like that. And we can see that it does improve our accuracy because it's able to move to those points. Make sense? All right. Well, that's what I have for you guys today. And other than that, have a wonderful day.